Welcome to Spring LIB.
For this problem, we need to find the time it takes to run each section. So for the first section, you travel 200 meters east at an average speed of 5 meters per second. We know that the distance one travels is simply the velocity, or the average velocity, times time, assuming no acceleration and no initial starting position. So if we want to find the time for the first section of this run, time is simply the distance over the velocity, which in this case is 200 meters divided by 5.0 meters per second. And so that gives us a time of 40 seconds for the first half. Now, for the second half of this run, the distance covered is 280 meters. Let's call this T2 and call these T1. There's going to be 2 times here, so let's not get them confused. So T2 is going to be 280 divided by 4.0. Which gives T2 70 seconds. Now, if we want to find the average speed, we don't care about the direction that the runner ran in. It's almost like they were running in the same direction the entire time. So to find the average speed, we know that speed is given by distance over time. So taking the total distance traveled, and let's call this S. Or just call it speed, just to be extra clear, because I'll call the velocity V. So then the average speed is simply 200 plus 280 divided by 40 plus 70. Or in other words, it's the total distance divided by the total time. Putting this on a calculator. And we get that the average speed to 2 significant figures is 4.4 meters per second. Now, if we want to find the average velocity, we care about the sign, because velocity is a vector. So instead of just taking the total distance covered here, we're actually going to take the total displacement. So if you start running 200 meters to the right, and then run 280 meters back to the left, your total displacement is going to be negative 80 meters over the same amount of time. So now the velocity is just going to be negative 80 meters divided by 110 seconds, the total time. Putting this into a calculator, and we get that the velocity is negative 0.73 meters per second, and it should be negative.